Hey guys, welcome to your Chapter 4, Lesson 4, Notes on Graphing a Function Rule. In fact, we'll graph several function rules today. By the end of the day, you will be able to graph any equation that represents a function. As a warm-up, let's remind ourselves what it means to evaluate an expression. To evaluate means find out what it's really worth, find its value, if you will. And how we do that is we make a table. It gave you the x values. It says, hey, when x equals these numbers, find out what this expression is going to be. So I put them in a table. First, I listed all the x's here. And then I say, okay, well, 2x plus 1, we're going to plug in. We're going to substitute x in for x. So here in our first row, we have x is negative 2. So I'm going to plug in a little negative 2 there. Negative 2 times negative 2 is 4. 4 plus 1 is 5. So that's our first answer. It's 5. When x is negative 2, this expression is 5. Nice. Okay, I'm going to highlight it a little bit as my answer. There we go. Okay. Moving on. So our next one, we're going to plug in negative 1 for x. Negative 2 times negative 1 plus 1 is the same thing as 2 plus 1, which is 3. So when x is negative 1, y is 3. Or not y, but just that expression is 3. Negative 2 times 0 is 0 plus 1, which is 1. And then we keep doing that. Negative 2, plug in 1. Plus 1 is negative 2 plus 1, which is negative 1. And finally, we have negative 2 times 3 plus 1, which is 6. Just kidding, negative 6 plus 1, which is negative 5. Oh, I haven't been highlighting my answers. There we go. Also notice how the difference here, each time we get a new expression, it's minus 2, minus 2, minus 2. Minus 4. What? Well, that's because our jump was twice as big here. We had a plus 2 instead of plus 1, plus 1, plus 1 each time. The fact that this changes by minus 2 for each time x changes, and the fact that this is a minus 2 is no accident. But we will dive more into that at a later date. Just be looking for patterns like that. Okay, it's not important right now. That's great, but how does this translate into a graph? Well, let's say we take that exact same function rule, the rule negative 2x plus 1, and we say, okay, well, this time, every time you have an x, y is going to be that value. All we have to do is take our same table, and this time, since we know that that is equal to y, we can say, oh, hey, all these guys, these are our y values. Hey, we made a table, we plugged in x into our expression, and now we have y values to spit it out. Excellent. Now, excellent, get it? Now we can make xy pairs. So we can take whatever x was, pair it with a y, and that gives us points. So here our x's are these guys, our y's are these guys. Let's put them in points. So we have the point negative 2, 5, negative 1, 3, 0, 1, 1, negative 1, and 3, negative 5. This is the only step that I'm going to actually put them into points for you. In the future, I will just look at this table and say, okay, negative 2, 5, negative 1, 3, like that. So now we have our points. Let's put them on our graph. Remember that our x-axis, our inputs, our independents go horizontally, and our y's, our dependents, our outputs, keep switching them, go here. Okay, so we go back negative 2, up 5, negative 1, 3, negative 0, 1, over 1, down 1, over 3, down negative 5. Nope. Now if we did this right, this is a linear function. They should all connect in one straight line. Ta-da! Excellent. Big ol' straight line. Check that out. Cool. So this time, I gave you what x's. I gave you the inputs that you should have. Notice there are 3 types of inputs. You have negative inputs. You have positive inputs. Sorry. You have positive inputs. And you have a 0. You have 0. Always use 0 because it's easy. And then use convenient numbers. Use easy numbers, but you should always have a negative and a positive. Unless, in the situation, it doesn't make sense. But let's look at this guy. So the function rule, W equals 146C plus 30,000 equals the total weight. Okay, I'm going to tell you right now, since we've got this equal to something, this is dependent. The total weight in pounds of a concrete mixer truck that carries C cubic feet of concrete. So the volume of concrete will influence how much the truck weighs. If the capacity of the truck is about 200 cubic feet, what's a reasonable graph of the function rule? Okay, so capacity is volume, how much it has inside. It can hold up to 200 feet, which means we shouldn't be plugging in more than 200 for our, we should be plugging in 200 for our cubic feet, for our capacity. So let's make a chart. We know we've got our cubic feet, C, our volume of concrete. We've got our weight, W of the truck. And we also know our rule. That 146 times C plus 30,000, equals W. So the way I make my table is I don't just make like a CW table. I leave space in the middle here so that I can do some work. Here we go. Now I've got my table. Now I need to pick values of C that are both convenient, but that also make sense in the context of the problem. For example, you can't have like negative feet of concrete, so we should just start at 0. And you also can't have more than 200 cubic feet of concrete. So that should be our maximum. We should go up to 200 because you can't have more than that. So now we need to figure out what our W is going to be. Well, we plug them in, we take our C's and we plug them in for C here. So that would be 146 times whatever our C is plus 30,000. Whatever that comes out to be, that's going to be our weight. So since we're going to do this rule, this pattern for all of our numbers, I'm going to drag it down here, and we know our last one is 200. Now really to make a line, you only need 2 points. So we could do, okay, 146 times 0, which is 0, plus 30,000 is 30,000. Great, we got that point. And now on the bottom, 146 times 200 plus 30,000 is 59,200. Okay, great, and we could make a line out of that, but it's always good to have at least 3 points. We're gonna do 5 just for the fun of it, for easy graphing. So let's say we want easy numbers here. So let's pick 100, let's pick 50, let's pick something in the middle. How about 22? Just cause. I don't know about you, but I'm feeling 22. Everything's gonna be all right if you plug in your X values too. Okay. Well, anyway, you don't know your W values, but I bet you want to. So plug in your C values into this function and see what comes out. See what comes out. You end up getting 33,212 pounds, 37,300 pounds, 44,600 pounds. So what does this mean? Well, let's put it on the graph, shall we? So the volume of concrete is going to go along our x-axis. Actually, in this case, is our c-axis. So we need to make some labels that go with the values in our table. Label, table. So it goes from 0 to 200. So let's make our table go for our graph, make our graph go from 0 all the way to 200, which means this will be 100 This will be 50. Boom, we've got a nice axis going on here. Similarly, our vertical axis is going to be the weight of the truck. Maybe we can make a straight line. There it goes. It's not right on there. Oh well, we're going to deal. And we know the weight goes from 30,000 to 59,200. Now, I'm not going to write the thousands every time. I'm just going to mark them in thousands of pounds. This is almost 60,000, so we'll go up to 60,000. Notice I put thousands here so I don't have to write the whole number, which means this would be 30,000, this would be 45,000, and this would be 15,000 pounds. Guys, that's like a ton of work. Get it? Ton is 2,000 pounds. Okay, anyway. So now that we know our points, we can plug them in on our graph. With no concrete, the truck weighs 30,000 pounds, giving us a point right here. With 22, whose idea was that? It was mine. With 22 cubic feet, it gives 33, approximately 33. So that's going to be about here. Let's put a little question mark because we're not sure yet. But with 50, we go up to 44,600. Just going to be like here. With 100, we go up to, that was wrong. That's where 100 should be. Okay. With 50, we go up to 37,300. Just be like here. And with 200, we go up to 59,200. Which is about here. Now, if we did this right, they should all lie on the same line. They should, but that just means our graph is a little inaccurate. There we go. Good enough. Ta-da! We made a graph. It's linear. There. That's how you do it. You take one variable, you plug it into your rule, and you get your coordinates. Nice. Now this graph continues for the whole graph. It's all line. It's not just points. This is because we can have any amount of cubic feet of concrete. We can have 1.5 cubic feet of concrete. We can have 122 cubic feet of concrete. It can be anywhere. So this graph, we call it continuous because a continuous graph continues. It's continuous. It continues forever. It's connected. It doesn't have any gaps. It's a graph that just looks like this. Okay? A discrete graph, on the other hand, is similar, but the reason it's called discrete is because the points aren't connected. They're individual points, like that. So it's the same relationship. It's just this one is all connected and this one is separate. So we say it's discrete or continuous. Okay, I'm going to show you an example of a situation that has a discrete situation and a continuous situation. So here we're making cheese. We're going to sell it at the farmer's market. The amount of milk used to make the cheese is shown, and the price, for the number of cheeses shown, and the amount that you buy it for is there. Okay, so here we've got our weight. We've got the milk. Oh, I switched them. We've got the weight of cheese made versus the amount of milk. Maybe it's cups or gallons. I don't know. Needed to make the cheese. Okay. Now on this lower table, we've got how the number of cheeses sold and the price, the amount of dollars. The dollar amount, that's the normal English way to say it, the dollar amount of the sale. Okay. You can already look at this relationship and you can say, ooh, this is convenient, that W is equal to 16M. So you need 16 ounces. Or if you have 1 gallon of milk, that'll make 16 ounces of cheese. But notice you can have half a gallon of milk to make 8 ounces of cheese. That's fine. You can have 5 gallons, whatever. That's great. That's cool. You can have like 5.5. It can be anywhere in there. So this one is going to be continuous, because you're allowed to have half. However, for the number of cheeses sold, you can't sell like half of a cheese. You can sell a smaller cheese, but it's one. You sell one thing. Okay. Here our function is, we say the amount is $9 times the number of cheeses you sold. He can only sell like one thing. This is going to be discrete because you don't cut your cheese in half. Don't cut the cheese, guys. So my question for you to remember the difference between discrete and continuous is, can you have half? Because if it makes sense to have half of the thing, then it is continuous. But if you can't have half of one thing, then it's going to be discrete. Okay, let's graph it real quick. So to graph the weight of the cheese, let's see, we go 1, 2, 3, 4 milks, 4 pounds of milk, 4 gallons of milk, whatever that was, by the weight of cheese made. Seriously. They just want to connect. Okay, anyway. That stands for weight. Let's see, we go up to 64. That's inconvenient. What if I made this 80? So if this is 80, 60, 40, 20. Nice. Okay. So our points, we've got the amount of milk is our independent variable. Our weight is our dependent variable. Super duper. So that's 0, 0, 116, 232, 348, and 464. Right there. Now again, because weight is continuous, you can connect them all because you're allowed to have half a pound. That's fine. Oops, my line missed my points. Good enough. Excellent. Now remember that we're not just looking at the weight, we're also looking at the amount of money we get after selling a certain number of cheese wheels, cheese wedges, bags of shredded cheese. However you want to sell your cheese, that's how we're selling them. Okay, now since the number sold is our independent variable, that goes down here. And that ranges from 0 to 4 again. Oh, that's so convenient. Watch this magic trick. Yoink. Haha, okay. And then up here we've got the dollar amount earned. Oh, good thing that's green, because dollars are green. Dollars earned. Nice. That goes up to almost 40. So make that 30. That's 20. And that's 10. So if we sell 0 cheeses, we get $0. We tried. Sell 1 cheese, we get $9. Sell 2 cheeses, get $18. We sell 3 cheeses. It's kind of pizza, isn't it? We get $27. We sell 4 cheeses. That's even a better pizza. $36. Now, again, we can't sell like 2.5 cheeses. So our graph is just discrete. It's just the dots. I'm going to make my dots bigger so you can see them. Ta-da! That's our graph. Okay, cool. What if we don't have a fancy situation? We just got a real funky mess going on here because this is not a line. Well, guess what, guys? The same approach applies. Just make a table. make a table with your x and your y, and then whatever y is equal to, your rule, that's going to go in the middle. So that's absolute value of x minus 4. And there you go. You got a magic table. Now again, pick some x values that are, some that are negative. Always pick 0 because it's easy. Pick some positives. So you can have -2, -1, 0, 1, 2, 3. If you want, those are my go-tos. You really don't need so many. You should have at least 3 or 4. 5 is good. Anyway, so let's plug them in. So all you do is you take your expression and say, okay, the absolute value of whatever x is, I'm going to take that and then I'm going to subtract 4 from it. I'm going to do that for every single value I have in my table. So I'm going to take all my x's and I'm going to plug them in. I'm going to say what that is. Absolute value of -2 is 2. Minus 4 is -2. I got itself. Oh well. Absolute value of -1 minus 4 is 1 minus 4. 0 minus 4 is 4. 1 minus 4 is, hey, that's cool. 3 minus 4 is -1. Well, to put us in a negative mood. But oh well. Now let's make our x and y axes. And this time, they didn't come with numbers. We need to put some numbers on here. How do I know what numbers to use on my x-axis? Well, I look at my x numbers that I have. Go from -2 up to 3. Since I put this in the middle, just be like, okay, well, blip, blip, -2, 2, blip, blip, 4. Okay, cool. And how are my y's doing? Oh, maybe I shouldn't have put this in the middle. Because look, they're all negative. I need to be able to get down to -4. So let's try every other one. -1, -2, -3, -4. Nailed it. This is 1, this is 2. Just for good measure. Get it? Measure. Okay, now we look at our points. When x is -2, y is -2. So we have -2, -2. Goes right there. Next, when x is -1, y is -3. So go down -1. -3. Radical. And then 0, -4, over 0, down -4. Cool. Now just looking at this, you would think, oh, hey, I've got a nice little pattern. I've got this nice little line. It's just going to go like this forever, except it doesn't even go through my points. So it should go like this forever, right? Wrong. This is why we also have positives. We have 1, -3, is right there. And 3, -1, is right here. This tells you that your absolute value function actually goes like this. Haha, isn't that great? But wait, Miss Van Dyke, why is this continuous and not discrete? Because we only plugged in these numbers. Shouldn't we just have these points? Well, you're going to connect them because this is for every single x. Every single x in existence. It can be a half. It can be -3024.8. Repeating. Because it covers all of them, we're going to connect these guys all together. Last one. Maybe I should leave this as an exercise for the reader. I'm going to run through it. XY table, and in the middle, x squared plus 1. Same rule applies. Pick some negatives. Pick some positives. Yay, maybe I was feeling odd. And then take your rule and plug your x in for your rule. So that'll give you x squared plus 1 for each of these guys. Okay, so you have -3 in parentheses squared plus 1, which is 10. -1 in parentheses squared, 1 plus 1 is 2. 0 squared plus 1 is 1. 1 squared plus 1 is 2. And 3 squared plus 1 is 10. Notice we have no negative y's, so I'm going to put my x all the way at the bottom. my x's go 1, 2, -3. 1, 2, 3. And I go all the way up to 10. I guess I'll just make these 2. So 1, 2, 3, 4, 5. No, I want to make them go higher. 2, 4, 6, 8, 10, 12, 14, 16. Why? Because I know this graph. I've done it before. Okay, so you have -3 all the way up to 10. -1 all the way up to 2. Thank you. 0, 1, 1, 2, 3, 10, and spoiler alert, it's 4. Where are you? 4? This line. 4, 17, and -4, 17 as well. Okay, so this graph is not a V like absolute value. It's actually a U. Like you are almost done with your notes. Whoops, I missed. Let's make it a really big point. Okay, cool. Ta-da! You did it. You did it. So again, take your x, plug it into your rule. That gives you your y, gives you your y. And then you have a nice set of points to go on your graph. Have a fantastic time on your homework. Yeah, hope it continues to be fun.